Hello dear students, welcome back to my YouTube channel. I guess I am audible and visible to all of you. Good evening, beta. Good evening, good evening, good evening. So I need to just wait for a couple of minutes so that I can check the visibility and the audibility of my video, right? Then I will start the lecture number second of current electricity. What happens to it? Just give me 1 second. I need to fix it out. 1 second, beta. Not getting my voice. Okay, now everything is great. Good to go. Okay. Yes. So I hope that you had watched my previous lecture of electric current, right? The first one in which we discussed about what electric current basically is, the basics of electric current, the direction of current if we have positive and the negative charge particles, then how to apply the mole concept, how to apply the hydrogen concept, right? I guess these things we discussed in our last class, that is yesterday's class. So in today's class, okay, so let us start today's class. I guess my voice is fully audible now. Today's class. Yes. Okay. So let's just start the class with the model of electrical conduction. Okay, it's lecture number second. The first topic that we will discuss here, first topic would be model. Model of electrical conduction. Electrical conduction. Meaning would be that how different parameters affect their current. We are going to discuss the minute things. Okay. Very first thing that we will discuss, it would be, let us suppose we have a conductor and we had not applied any external electric field, or means the battery or the cell. First part. Okay. The very first thing that we will discuss in this particular title, and it would be when no potential difference. Potential difference simply indicates battery. Potential difference, when no potential difference. Potential difference indicate what, beta? Battery or a cell is applied. Is applied. First condition, when no potential difference or a battery is applied. So therefore we can write the external electric field will be zero. The external electric field will be equals to zero. Done. Look now how to maintain. If we have a conductor, look, this is my conductor. Okay. if this particular figure is conductor, that means in this figure or in this diagram, my electrons are available. My electrons are available. My electrons are available. And we are discussing the behavior of this conductor at room temperature. Okay, we are discussing at room temperature. What will happen at room temperature? I guess room temperature simply indicates 27 degrees centigrade or 300 Kelvin. Okay, 300 Kelvin. Now look now. Here my conductor is having some free charge particles, and we are discussing the effect of temperature. Due to the temperature, what will happen? These electrons will move in a random direction. These electrons will move in any random order, any random direction. Okay, due to thermal energy. Due to what? Thermal energy. So due to this temperature, my electrons start moving. My electrons, these electrons start moving in a random motion or in random order. Random order. Okay. Why, sir? Because when we are giving temperature, so they will get thermal energy. They will get thermal energy. Due to this thermal energy, my electrons will get thermal velocity or thermal speed. They will get what? Thermal velocity or thermal speed. Okay, very important thing. Due to this temperature, these electrons will get some energy now, due to which they start moving in a very random direction. The velocity is known as thermal velocity or what? Thermal speed. Done? Done, na? 1 second, 1 second, 1 second. Okay, now look beta. Look here. Okay, now what will happen here now? Look now. If we talk about, if we are giving energy, thermal energy, due to this thermal energy, my particles start moving. The velocity that the particle is getting, it has a separate name known as VRMS. Okay, so I will write here the gain speed or the speed gained. Okay, right here now. The speed gained. The speed gained by virtue of temperature. By virtue of temperature is known as VRMS. VRMS. It is known as VRMS. Done. So how to deal with all these things? Now look here. Look here, beta. These particles gain energy. So I can write kinetic energy 1 by 2 mv square. But it is RMS, no? Is equals to 3 by 2 kT. 3 by 2 kT. What is K? Boltzmann constant. What is T? Temperature. Okay, I will write the notation part it now. M means mass of electron. VRMS root mean square. What is K? Boltzmann's constant. What is T? Temperature. Done. So we will get now the speed. So VRMS will be equals to 2 cancel out. It will be equals to 3 kt under root of m, right, like this. If we place the values, so my answer would be 10 to power 5 meters per second. Okay. So what you need to get from this particular equation, that without giving any external electric field or a potential difference, due to the room temperature, these electrons move with the speed of 10 to power 5 meter per second. These electrons move with this particular speed, and this speed arises due to the temperature. That's why this speed is known as VRMS, or thermal speed. Done? Clear now? This one, no? Look here, look here, look here. I will take a cross-sectional area of it. I will take a small cross-sectional area. If I will take this small area, this cross-sectional area. Look, if charged particle is crossing this way, no? And maybe some other charged particle will cross it this way. Maybe. If, let us suppose, the first particle is crossing from left to right, there are a lot of charged particles. Na? Second one will flow from right to left. What will happen? Due to this one, my current will flow from like this. No? I will write it minus I. Suppose it is minus I. Due to this electron, my current will flow like this. It is plus I. So what is net current then? What is net current? Sir, net current would be minus I plus I. I guess it is 0. Yeah, we can say that yes, sir. Still, electrons are moving with 10 to power 5 meter per second speed, no? But still, the net current is 0. Still, the net current is 0. Why? Because this conductor in 1 meter square conductor, no? In 1 meter cube, no? In 1 meter cube of volume conductor, there are approximately 10 to power 26 meter cube electrons. These electrons are doing some random motion. So there is a possibility that if we are taking one cross-section area, some electron will flow like this, some will flow like this. So both will cut out their effect, so the net current will be 0. Net current is 0. Now, if somebody will ask you, what is average thermal velocity? If somebody will ask you, find average thermal velocity. I guess average thermal velocity is equal to 0. Do you know why? Suppose we are discussing about one electron. Look, this electron, it will go like this, then like this, like this. Okay, like this. Maybe no. Sometime it will cross its own original position. So displacement would be 0. If displacement is 0, so velocity is 0. But distance is not 0, so I will write average thermal speed. I will write average thermal speed. Average thermal speed is not equal to 0. These are two different things that you need to remember. Average thermal velocity is 0, but average thermal speed is not equal to 0. I can write this one. This one I can write it as a sir V average. Average velocity is equals to summation of their velocities V1, the summation of their velocities. If let us suppose n number of particles are present, n number, whole divided by n, it is average velocity, so it come out to be 0. And I told you the reason. Now look, displacement would be 0, so velocity is 0. Easy or tough? Huh? Any confusion, then you can just let me know here, right? We are just discussing some minute things, no? If you find any difficulty or anything like that, you can just ask me right now. There is no issue. You will find minute particle things. Now look, how sir velocity is 10 to power 5, but still my current is 0. Right? These things you need to remember. Why there is VRMS, right? These things. Okay. Next point. Next point would be mean free path. It is what? Mean free path. Mean free path. So what is mean free path? I will write first definition, then I will discuss it. Okay. It is denoted by lambda, and it is the average. Mean free path is average distance. Average distance traveled by an electron. Average distance traveled by an electron two successive between two successive collisions. Two successive collisions. So therefore, lambda is equals to total distance traveled. Total distance traveled divided by number of collisions. Okay, and its value is approximately given to us for metals. It is 10 angstrom for metals, specifically for metals. Okay, so if we are making here a conductor, look, it is a conductor. Here is a conductor now. Inside a conductor, positive ions are present. These little dots are positive ions, right? These are fixed. These are, it is fixed ions, fixed atoms. Or I will write fixed atoms also, right? Here, this one is what? Free electron. It is what? Free electron. Due to its thermal energy, it will strike this one, strike this one, strike this one. No? It will strike like this. No? It will strike. Now, total distance traveled. So we have to measure the whole distance. Look, so the particle is going from this to this one. The particle is going the right. Now look here. Now the particle is going from distance this particular point to this. Then particle is going from this particular to this. Then this one to this one. 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 Okay. The whole distance divided by number of collisions. It is one collision, two, three, four, five. Okay, and the value that we will get now, the average value, it is the mean free path. It is what? Mean free path. I am giving a very basic definition here. What is mean free path? Average distance traveled by an atom between two successive collisions. It is the average of all. No? Look, what is sir mean? No? Mean means simply, look, one collision, okay, second collision, okay, third collision, okay, fourth, fifth, and sixth collision. I have to take the mean of the six collisions, and it gives us with the idea of mean free path denoted with the symbol of lambda. Walaikum assalam, beta. Okay, we need to understand the basics of it. No? Look, in the coming lectures, we will be discussing some great numericals from JEE Advanced or some mains and NEET, like the Olympiads also. So there you don't be hesitate. Sir, what is this lambda? What is the meaning of it? How to derive it? Okay. Look now. Second point is it is relaxation time. Next point would be relaxation time. It is a relaxation time. It is what? Beta relaxation time. And a relaxation time is denoted with the symbol of tau. Okay. And definition of it, it is the average time. Average time taken by an electron. Average time taken by the electron between two successive collisions. Two successive collisions. You okay? So you are writing it now, beta? Good vibes. You are writing this thing. Which one? This one? This one? You can do one thing. No? You can just take a screenshot of it. No, I guess the YouTube allows you to take a screenshot. No, you can take the screenshot. No, or you can do one thing. Now, if I am just writing, just write with me. No, then I'm just explaining these things. Then you need to stop writing. Okay. Thank you, beta. It is average. It is relaxation time means it is the average time taken by an electron between two successive collisions. That means look here. Whatever write here. Look here. Suppose particles are going from look from this to this one collision. So it takes time. Let us suppose tau one. From this one to this one, it is tau two. This one to this one, it is tau three. This one is tau four. Then tau five. Then tau six. Right now, I need to take the average of all these things. Okay, so I will write tau one, tau two, tau three, tau four, tau five, tau six is whole divided by six. So the final result that I will get now, that thing is known as the relaxation time. So now how to define the relaxation time? So it is tau. I will write it total time. What is it? It is total time between two successive collisions. Between two successive collisions divided by number of, or I can one more thing for all electrons, divided by number of all electrons. Can I like this also, right? And it is value is approximately now. It is value is approximately given to us. It is 10 to power minus 14 seconds, and specifically for metals. So thermal speed 10 to power 5. Okay, then this mean free path 10 angstrom for metals. Now this tau it is 10 to power minus 14 seconds for metals. Now this was the whole thing that we need to discuss now. When the no external field is applied to our conductor, what will happen? So this is the whole sum. No? You need to just take all these things in your mind. How our conductor behaves if we have not applied any external field or any battery. Okay, so what is collision? Collision means strike. Okay, look, this is one thing. Now, if my hand is striking on it, now there is a collision. Okay, collision. This is collision. There is no fun of writing this thing, right? Okay, now second part. Now we will discuss second part number B. Part B. Part B is behavior. Behavior of a conductor. Behavior of a conductor. Behavior of a conductor in the presence of electric field or in the presence of external voltage. One second, beta. You need to give me 1 second, okay? There is some person who just spam me. 1 second, beta. Okay, now everything is good to go. Okay, it happens now. Okay, now look now. Now we will define that what will be the behavior of a conductor if applied, we had some external applied voltage. That means if we're applying some battery to our conductor. Okay, look, if this is my conductor, if this is my conductor, okay, now we are applying some battery to it. Battery means potential difference with some potential difference V. Okay, what will happen now? This is positive terminal, this is negative. So this will be positive and this will be negative. I guess here one thing will be there now. What's our electric field? There will be now electric field. And electric field direction is always from positive to negative. This thing we discussed in our previous class. Look now, every class is just mixed now. It is clear? It's combined. Now what will happen now? Now, if here is electron, there are a lot of electrons, not 10 to the power 28. Now what will happen? Look, if electric field is going from left to right, this electron will feel a force opposite to that of what? Opposite to that of our electric field. I guess you know it. I guess you know it, no? Why this electron will feel a force opposite to the electric field? You know it. And we had the discussion on in the previous classes, no? Yes, sir. Now I can write force. Look, force is there, so there will be an acceleration. So I can write mass into acceleration. And this force is equals to charge of electron into electric field equals to mass into acceleration. Now this electron will be in an accelerated mode, and its acceleration I can write it as a E by m. This thing you need to remember. Acceleration of an electron in an external electric field would be E by m. Or if you want to write it in vector forms, it is minus E divided by m. Easy, no? It is very easy. It's very easy, no? Everything is not, everything is what? Connected. If there is no voltage, so there won't be any kind of acceleration, no? Okay, now look what will happen now. Now what will happen? Look now. Now I will make a diagram now. A big one. Okay, a big one now. A big one now. Look. Look near. Here, this is my electron, right? My electron will go like this. One collision, then it will go like this. second collision here, third collision, then it will go like this. Okay, now like this one, suppose it will go like this now, then it will go like this one, suppose not suppose, then it will go like this one. This is the path of my electron. This is the path of my electron. So you can write it is path of my electron without applying voltage. Okay, this one is without potential difference. It what? Without potential difference. That means my electron is moving just because of thermal energy. Now second case, we now applied what? We now applied potential. So what will happen? What will happen? It will go like this, right? Look now. Now what is this one? Red one. It is with potential difference. It is with potential difference. It is with potential difference. You can see now, initially, my electron is here, no? But when we are applying potential difference, it gets dragged up to this particular point. No, it gets dragged. This is what? It gets dragged. Okay? No, second one means with potential difference means if we are applying battery. First one is without battery. Second one is with battery. When we are applying battery, there is a random motion. Yeah, there is a random motion. But with the random motion, there is a dragness also, right? Look now. Here, if we are applying the battery here, it is positive, negative. So this electron will face a force in this way. It is force. Due to this force, it gets dragged towards the rightwards. It gets dragged towards the. थैंक यू बेटा जी. नहीं, अगर मेरे पास एक बच्चा भी होगा ना तो तब भी वही क्लास होगी. 1000 में वही क्लास होगी ना. I feel there's a need of this kind of study things, right? That's why I'm here. I don't want these kinds of watching things, right? Don't worry about it. Look now, so this electron gets dragged. The velocity, now look now, the velocity by which your electron gets dragged, this velocity is known as drift velocity. Easy, no? This velocity is known as drift velocity. So if now I need to write the definition of it, if I need to write the definition of drift velocity, if I need to write the value of drift velocity, definition of drift velocity, so I can write velocity, I can write velocity with which, I can write velocity with which the free electrons get drifted towards positive terminal, towards positive terminal. So this velocity is known as drift velocity. This velocity known as drift velocity. Done. And one more, I can add the most important thing. No? One most important thing, and that is now look, the most important thing. If we talk about the NCRT, if we talk about the NCERT, okay, NCRT just told us these are not straight lines. No? If I am just denoting these things in a straight line, these are not straight lines. Just mark these words, right? These are not straight words, straight line. These are parabolic. You can write these are slightly curved. These are slightly curved. Or you can write these are parabolic. These are parabolic. these lines, these are not straight lines. Yeah, we can just show it now for our simplicity now, for our ease, right? We are showing a straight line curve, but these are what? Parabolic curve. These are parabolic curve. Done? But it's a curved parabolic. No, it's an NCRT line. You need to mark it for. Okay? Okay, look now. Look now here. Look now here. So we know that there are n number of free electrons. In this particular diagram or particular conductor, there are n number of free electrons. There are n number of free electrons. Now, if I need to write the equation of it, can I write for one? We know that the V is equals to U plus AT. We know this one now from kinematics. For first electron, can I write V1 equals to U1 plus A is constant for everyone, that it is tau 1. Can I write like this? Yes, NCRT is extremely important for your NEET or JEE. Extremely important. You will find a maximum things there, no? Look, I will give an example. If you had discussed and if you have studied about the Coulomb's law, F equals to K Q1 Q2 by R square, but you have not heard of anything regarding the torque. Have you ever heard about the torque applied in the Coulomb's law? But if you read NCRT, you will find the line on it. No, you find the line on it. There are numerous things, no, written in your NCRT. You need to just read NCRT. Each single line of NCRT, each single numerical, solved or unsolved, you need to read it. You need to get the answers. Okay? You can do one thing. Now, look, you can do one thing. After completing a lecture or after completing a whole chapter, let's suppose you had completed the electrostatic. Now, for once, just read your NCRT thoroughly. Just read your NCRT thoroughly, right? Do the numericals, solved or unsolved. After that, just connect it with me. Okay? You will tell me now. So, what is the difference then in your preparation when you are just doing calculation from NCRT, right? Look now. For first electron, I will write this equation. For second electron, I will write V2 plus U2 plus AT2. For nth number of electron, Vn equals to, here is equals to, no? Equals to Un plus A tau n. Now write the whole thing now. What is V net now? If I need to write V net, what is V net now? V net. I guess V net is equals to V1 plus V2 plus so on up to Vn whole divided by n. It is the average value, no? Is it average value? Yes. Put V as U1. I can write U1 plus A tau 1. I can write like this, no? Plus U2 now. It is U2 now plus A tau 2 plus so on. It is Un plus A tau n whole divided by n. I can write in this way also. It is U1 plus U2 plus U3 plus so on up to Un whole divided by the n plus I will take A common. It is A common. Then tau 1 plus tau 2 up to tau n whole divided by n. In the previous slide, we discussed that this whole term, this whole term is 0. This is what? 0. I can write V is equals to 0 plus A. And this thing is known as average relaxation time tau. It is A tau. So this is equals to drift velocity is equals to A tau. And what is acceleration? What is acceleration? Sir, acceleration is EE by M. Acceleration is EE by M. So I can write VD is equals to EE by M. Then we have tau. So this is my relation of drift velocity. What is drift velocity? Charge of electron, electric field, average relaxation time whole divided by mass of electron. This was a derivation of drift velocity. Easy or tough? N means N means number of electrons. N means number of electrons. It is not number density. That is small n. Small n is number density. Okay. It is capital N. Okay. You need to be no. We need to be very good in the derivational part, right? Because we need to we need to. Yeah. Minus E simply indicates if we are doing in vectors. That is also correct. Why? Because charge of electron is minus E. No. It is not wrong, right? And this is not wrong also. Look now, beta. Look now. And if we are placing all these values, tau we know. When tau we know, na? 10 to the power minus 14. Electric field, EM. If we are placing these values, we will get a one constant value. It is 10 to the power minus 4 meter per second. Okay. So look here. There is a one question. Na? I will ask you one question. Na? One question from my end. One question from my end. I will give you first homework. That is, if we are having acceleration, if acceleration is not equal to 0, so I will write it as an accelerated motion. I will write as an accelerated motion. So in accelerated motion, my velocity is variable. My velocity is variable. It is not constant. It is not constant. But here you can see now, my electron is in accelerated motion. Still, my velocity is constant. How? Still, my velocity is constant. How? You need to find this answer. Acceleration is there. Velocity needs to be variable. But here my velocity is constant. You need to find this the reason why my velocity is constant here. You need to find it. Okay. Now we will just manipulate these equations now. Manipulate. Do you know one thing that? Do you know one thing from electrostatic? What, sir? E is equals to V by L. Do you know it? Then I can write Vd is equals to EV tau divided by ml. One more relation to find drift velocity. No, acceleration is not 0. If acceleration is 0, so we cannot say it is accelerated motion. No? It is accelerated motion. It is not equal to 0. Acceleration is there. Acceleration is there. Okay. Next term is mobility. Next term is mobility. Mobility. What is mobility? Mobility means if we are giving electric field, if we are giving the electric field, with this electric field, how my electron get drifted. Mobility simply indicates how electron gets drifted if we are given some electric field. So simply indicates it is mu, which is equals to magnitude of drift velocity divided by the electric field. Okay, and it is always positive. It is always positive. So mobility means magnitude of drift velocity to the electric field. And if we talk about its unit, drift velocity, it is Vd and E. So it would be meter square volt second. Now you need to just think about it. No? Tomorrow I will be asking. I will ask you for this numerical. No? Tomorrow you need to give me the value of it. Why, sir? There is acceleration always and constant velocity is there, right? Now look, mobility mu. What is Vd? It is E tau by m. I can write E tau by m whole divided by E. E cancel out, so I can write E tau by m. So this is mobility equation. E tau by m. Okay. So there was a numerical from it. Now for NEET, numerical for NEET. No, the numerical was Vd is equals to E times mu. This was asked in NEET. Okay. What is E tau? What is E tau? Which one? Which one is E tau by m? Which one, beta? Yeah, it is mu is E tau by m, no? I am giving you the tau. Tau means time. Tau means time. It is E tau by m, no? Okay. Now we need to find a relation between current. What we have now? Relation between current and drift velocity. It is current and drift velocity. Current and drift velocity. Relation between current and drift velocity. Look, beta. This is my conductor. This white thing is known as my conductor. Okay. And its area of cross section is A. Area of cross section is A. And length is L. Length is L. If radius is R. If radius is R, what is volume? Volume is A into L. Volume means area into length. Yes. It is not AEVD. It is NEAVD. Done? Done now? Look now. Look now. What is current? Sir, current is simply it is del Q by del T. Correct? So now we need to find del Q. Do you know what is del Q? You know what is del Q? It is number of charges in the whole volume. Okay, I can write here number of charge into my volume, then divide by delta T. Done now? I. Number of charge per unit volume. Then volume now. I can write N means number of charge per unit volume. Per unit volume. Then volume get cancel out. So I can write, sir, it is N. Volume. What is volume? Volume is A into L. Clear? But charges is N times E. Quantization. Whole divided by delta T. What is delta T? I can write delta T as a delta T. Okay? Delta T as a delta T. And we know that, sir, speed is equals to distance by time. It is distance by, yes, but number density is time. It is distance by time. Speed is Vd, distance is t, L, time is delta t. So delta t came out to be, it is L by Vd. So here I can write it is NEAL whole divided by V, it is L, then multiplied by Vd. LL cancel out. LL cancel out. So my current came out to be NEAVD. So my current comes out to be NEAVD. So what is N here? You can write electron density also. I will write the name electron density or number of electron per unit volume. Per unit volume. Okay. What is E? What is E? Charge on electron. What is A? Area of cross section. Area of cross section. What is Vd? Drift velocity. What is I? Current. So my current equals to NEAVD. My current is equal to how much? Sir, NEAVD. We can manipulate now it. Look now, look now, look now. What is I now? Sir, I is equals to NEAVD. Or I can write, sir, VD is equals to I divided by NEA. Can I write like this? Yes, sir. We can write like this, no? Simple. One more formula. What is VD? Sir, VD is E tau by M. What is E? Sir, E is V by L. So I can write it EV tau by ML. Now, two formulas, two usage. If in your numerical, if your current is constant, if you are in numerical, if your current is constant, so you need to apply this numeric, this formula. And if your potential difference is constant, if your V is constant, you need to apply this formula. Look now, both formula is used to get my potential difference. Both formula, you need to mail now. You need to mail your organization. Then when we need more sessions, right? Then it is up to you. Okay. Look here. If your current is constant and you need to get potential difference. Sorry, if your current is constant and you need to get your drifting velocity, use the equation I divided by NEA. But if your V is constant, don't use I by NEAV. You need to write EV tau by ML. Different formulas, different usage. Then suppose. If in our numerical, we had a numerical. If in our numerical, it is asked us that if a radius gets doubled, if the radius gets doubled, find the effect in potential, yes, drift velocity. Okay, look here. If we talk about this particular equation, this one, what is E? E is charged electron, V is potential, T is time, M is mass, L is length. So there is no term related with the radius. So here, no effect. But if we use this formula, I is constant, N is there, E is there, A area. What is area? It is pi r square. I can write VD equal inversely 1 by A. Inversely 1 by pi r square is pi r square, no? So VD inversely 1 by, it is doubled. So it is 1 by 4. Different formulas, different result. So we have different formulas, different result, right? Okay, one more numerical now. One more numerical. Numerical will give you the sense now how you need to manipulate your numericals, equations. Suppose we have a numerical. Numerical states that we have two sort of conductors joined in a series way. Two conductors joined in a series manner. Joined in a series manner. Then radius of is given to us r. Radius is given us r. Material is different. We had different material. What we had now? Different material. Now charge density N1 is to N2 is given us 1 is to 4. Charge densities ratio is given to us. Find VD1 to VD2. How to get this numerical now? Look beta. One thing that we can deduct from this one now. Look, if let us suppose current I is flowing in this manner, I guess this current I will flow like the same. Okay, sir. If current is flowing the same, that means current, I can write current is constant. If current is constant, which equation I need to use? VD. I equals to NEA. Current is same. Charge carrier E is same. Okay. Sir, area is same. So therefore, VD is inversely proportional to the N. So can I write now VD1 to VD2 is equals to N2 by N1? N2 is 4, it is 4 by 1. This is my answer. Very shortcut way answer. Okay? It is very shortcut way to get this things done. Any doubts now? No doubt? Easy now? 1 second. Okay, look now. Look now. Look now. Look now. Suppose, do you know current? Current is a microscopic or a macroscopic. Which quantity is current is? Microscopic or microscopic? 1 minute, which one? You need to note down this one. Do one thing and take a screenshot of it, okay? So current is a microscopic quantity. Current is a macroscopic quantity. So this is my conductor. It's my conductor. If I need to study this particular point, if I need to study this particular point, to study this particular point, I need a microscopic quantity. I need a microscopic quantity to discuss this point now. So that microscopic quantity is known as current density. So what is micros? Okay, macro means bigger level. So if we are talking about the whole conductor, we will take a current thing. If we are talking about a single particular point, we will take a microscopic small thing, that is a microscopic quantity. We will discuss here what current density. Here we will take current density. Okay. So current density. So current density is a vector quantity. It is a vector quantity. Done. And it is magnitude. If we talk about it is magnitude, magnitude is equals to current by area. It is current by area. Done, no? Okay, it is a vector. I will write it as J. It is J vector. Okay, so I will write current density. It is J vector. It is current is I divided by area like this. Done. And it is direction. If we talk about the direction of current density, its direction is same as electric field. Same as electric field. If you want to get the direction of current density, you need to find the electric field. Okay. If you write J cross A, that it is the cross product. Cross product will give you the vector one, but then the scalar, na. So J cross A is the wrong. So direction of current density is same that of the electric field. Okay. So by this particular thing, you will write current is equals to J dot A. It is J dot A. Or it is J A cos theta. Done. J A cos theta. हाँ बेटा बोलिए क्या बोला आपके टीचर ने. Okay, so it is J A cos theta. If we talk about it is unit. So what is I? I is ampere. So ampere meter square. If we talk about the dimensions, I can write L minus 2, it is A. Done, beta? Easy? Easy, na? Look now, I guess you are very good with, I guess you are very good with the electric field thing. Okay? Let us take an analogy. Let us take a similarity between the electric field and this current density. Suppose, look, beta, if these lines represent electric field lines, here, if these lines represent current density J. Now, look now. We have our area. My component is like this, area component. This area is making angle theta. If this is area A, so I can write it is A cos theta. A, this is A cos theta, na? It is A cos theta. Then, so what is flux? Flux is E. Then area is A cos theta. So here I will write flux instead of flux, I will write current. It will be how much? J A cos theta. Here flux, it is E dot A. Here current I, it is J dot A. Okay. If E is variable, if my E is variable, I know that we need to apply flux integration of E dot dA. If here my current is variable, sorry, my J is variable, I can write integration of J dA. So these are some formulas. Done? Easy now? Now we've done this one. Now let's take some examples by which we will have very great confidence which formula use at what particular time, right? Look now. Look now, beta. We had the numerical like if current density J is given us 2 I cap minus 3 J cap plus K cap J, and my area is given to me, it is area, it is 5 I cap minus J cap plus 2 K cap. Then find current. Which equation I need to use here? Simple, sir. It is J dot A. So I is equals to J dot A. Instead of J, I will write 2 I cap minus 3 J cap plus K cap. Now it is dot product with 5 I cap minus J cap plus 2 K cap. Now look, 2 into 5 is 10. It is 10. Minus minus plus 3 into 1 is 3 plus 2. So I guess it is 15. It is 15 ampere. So my current comes out to be 15 ampere. Okay, beta? Easy now? Easy? Done? Spammer gone? Okay. I just block this person now. Don't worry about it. Okay, just concentrate. So look now, if we have any numerical like this now, so we need to just apply J dot A only, okay? Dot product. Second numerical. Second numerical. Second numerical is we had a conductor like this. Look, this is my conductor. It's my conductor, okay? And my current is given as 10 ampere. And my area with angle 45 degree. This area is 2 meters square. Okay. Find J. Find J. How to find J? Sir, if theta is there, so I guess I can write I equals to JA cos theta. Okay, so J came out to be I divided by A cos theta. What is I? I is 10, A is 2, then we have cos 45 degree. 2 on the 2, 2 5 is 10, it is 5. It is 5. Cos 45 is how much? 1 by root 2. I guess my answer is 5 root 2. Okay, it is 5 root 2 now. It is 5 root 2. Yeah, this class will be of 90 minutes, right? 5 root 2. This class will be of 90 minutes. That was exactly at 12 o'clock we will end the class. Okay, but remember me, na? The time over. So now new numerical. So where we need to apply the variable concept? Suppose this is my conductor. This one is my conductor. Okay, with radius r. With radius r. Done. And my current density is a function of R. It is alpha into R. Alpha is some constant, no? It's R. So we need to get current. So in this way, how to get my current? I guess we know the equation. I equals to integration of JDA. Okay. Whenever in the physics you find this something, no? So go to the R, cut an element of width of this thickness dr. Thickness of dr. In whole physics, no? It is thickness is dr. Radius is r. Now it will looks like the circle now. R dr. Now cut it. It will looks like this now. Dr into r. Done. What is the area of this one? What is the area of this one? So this length will be 2 pi r, no? What is the area of it? So area is length into breadth. Length is 2 pi r, breadth is dr. So the area of this circle, this one, it is how much? It is 2 pi r into dr. So dA we got it, now dA. dA we got it. So can I write now, sir, I is integration of J. J is how much? It is alpha times R. What is R? What is this R? Sir, this R is, no, this dA. dA is how much? It is 2 pi R into dr. I. Look, alpha is constant, 2 constant, pi constant. Integration R is R square dr. Integrate is from 0 to R. 0 to R. I will write 2 pi alpha. Integration of R square would be R cube by 3. Upper limit is R, 0 is 0. Lower is 0. Okay. So I will write it is 2 by 3 pi alpha. It is R cube minus 0 cube. So I guess I came out to be, it is 2 by 3 pi alpha R cube. This is my answer. Or I have couple of references now. You don't need now because I am dealing with varieties of segments, right? That's why I need varieties of things. You don't need any reference book, no beta. Do one thing now. Watch my lecture. Watch my lecture. Do your homework. Then you have this sort of NCRT, solve it. Then PYQs, right? More than enough. Lecture, you will get your homework from your institute now, somewhere, then module, then your NCRT, more than enough. Done? Look now. So I just told you the functionality of my formulas, how to get these things done. Look now, look now, look now, look now. What is I? Sir, current. Current is equals to NEAVD. I can write I by A. I by A came out to be NEVD. I by A is current density. It is J. J. NE. VD is E tau by M. I will write J came out to be, it is N E square tau by M into E. Done? Look, for a conductor, for a single conductor, N is constant, no? E is constant, tau is constant, M is constant. So I will replace the whole bunch of properties in a single letter. So J is equals to, it is sigma times E. It is sigma times E. So I will write sigma is equals to N E square tau by M. This sigma is known as what? Conductivity. It is conductivity. Conductivity is the opposite of resistivity. Conductivity is equals to 1 divided by resistivity. Resistivity. Resistivity means it is what? 1 by rho. Done now? Sure, beta. If you have any logical question, you can ask me. So I can write here now. Look now. So J is a vector, just my sigma, sorry, rho. So we have now E. What is E now? E is also a vector. Done? So this one is known as microscopic form of Ohm's law. Microscopic form of Ohm's law. It is microscopic form of Ohm's law. Done? So here my conductivity, if you need to write conductivity, conductivity means the ease of flow of your charged particle in any conductor, right? It is how much? N E square tau by M. Resistivity means opposition to the flow of current. So it would be M divided by N E square tau. I guess these terms you have got if in your 10th standard, no? Conductivity, resistivity. If the length of the conductor is 1 meter and the area of cross section is 1 meter square, so resistance is equal to the resistance. Resistivity is resistance then. Okay. Look now. If you increase the temperature, if we increase the temperature, if we increase the temperature, the thermal speed of your electrons will increase. If the thermal speed increases, that simply indicates my average relaxation time decreases. If my average relaxation time decreases, so my drift velocity will decrease. If Vd will decrease, my resistivity will increase. हाँ, ये लॉजिकल आपका डाउट है कि न्यूमेरिकल में आपको ये इश्यूज आते हैं. देखो बेटा, फिजिक्स में इफ यू वांट टू गेट अ वेरी great confidence in solving any numerical, no? First of all, make sure that you have very good grip on the three chapters. Basic mathematics from 11th, vectors from 11th, units and dimensions from 11th. If you are very good in these three chapters, you can overcome these things, okay? These problems. You know why? Because in a single numerical, you need to apply two things. One is the basic formula. Basic formula you will get from the concept part. Then rest you think is basic maths. Okay, if you're just facing any doubt like this, so make sure that you have very good grip on these three chapters, then everything will get sorted. Look beta, same. What is J? J is sigma times E. What is J? It is current by area. Sigma I can write 1 by rho resistivity. What is E? What is E? I guess E is V by L. I will write delta V by L. So what is delta V now? Delta V is equals to I rho L by A. So can I write this? Delta V is equals to I into R. So this thing is what? R. This is what? Ohm's law. So one more derivation on Ohm's law. Easy, no? Very easy this one. Okay. Let us do a simple thing now. Simple thing. Look now. We have a conductor. with different cross-sectional area. A conductor with different cross-sectional area. Look, this one, the area is A1. This side, my area is A2. And we can say that sir, A1 is less than A2. We know it. And current is flowing. If current I is getting inside of it, it will leave not the same current I. Current is constant. Current is going from left to right. Current will flow from A1, same will flow from A2, and A1 is less than A2. So what is J? Sir, J is equals to I by A. I is constant. So can I write J is inversely proportional to the area? Clear? If A1 is more than A2, then can I write now what is J1 and J2 relation? Can I write now J1? Current density in this phase is more than current density in this phase. Okay. Now electric field. Now good beta. Okay. Now we will talk about E. One more formula. Sir, J is equals to sigma times E. This one is constant, so it is proportional to the E. So can I write E1 is more than E2 then? By this equation now? Now what is current E equals to NEAVD? I constant, N constant, E constant. Then VD is inversely proportional to the A. Can write VD1 is more than VD2. From the simple diagram, we concluded these four results. But the simple diagram, we concluded these four results. If cross section is less, so the drift velocity at that cross section will be more. Electric field will be more. Current density will be more. Done? Let us do one last part of today's class, then we can just end the class. Okay? Suppose in some numericals we will find we had a conductor, then we melt it and then reshape it, or we bend the conductor, or we stretch the conductor, or we compress the conductor. In whole cases, what we need to do? What we need to do now? Stretch, bend, melt. I guess in all the three cases, mass will be same, mass is same, and the volume is same. Both will be same now. Mass will be same. Then now mass is same, volume is same. Now look, what is volume? What is volume? Sir, I guess volume is area into length. I can write volume is area into length now. Done. Volume is same. That means area is inversely proportional to the length. Done. Area is then inversely proportional to the length. Now, sir, how to apply this concept in my numerical part? Look now. Look now. Right now, we just derive a relation. The resistance is equal to rho L by A. We conclude this thing. Two things now. Look now, for a shortcut purpose, R is equal to rho L by A. Just multiply it by L and divide it with L. One more thing, L by A. Multiply it with area, divide with area. R equals to rho. Again, it is L square by AL. R. Rho. LA divided by A square. Look, AL means volume. So here I can write R equals to rho L square by volume. R equals to rho A by A square. Sorry, V by A square. It is what? V by A square. Simply indicates V constant, rho constant, rho constant. That means if we are dealing with what? If we are dealing with only length, so my resistance is length square. If we are dealing with area, it is 1 by A square. Done now. Suppose my length changes, which formula I need to use? Sir, I will use R is proportional to the L square. If my area changes, then I will use R is proportional to 1 by A square. 1 by A square. So how to use it in my numericals now? How to use this thing in my numericals now? Look better. One more thing, then we will do numerical. One more thing. Let us do numerical. Nothing more than that. Numerical. Numerical like we have a wire. We increase its length by 30%. 30 is more now. Let's have 3%. 30 is more now. We increase the length of my wire by 3%. Increases. Okay. So then find percentage change in resistance. Percentage change in resistance. Which formula we need to use? Sir, length changes. Length changes, so R proportional to the L square. One thing. Second, it changes 3%. Look, if in your numerical, if it is less than 5%, if it is less than 5%, you can use direct formula. Direct formula. Okay. So I can write R proportional to the L square. So changes delta R by R into 100 percentage equals to, it is 2 times delta L by L into 100. Done. It is 2. I guess this thing is given to us 3%, 3%. So my answer came out to be 6%. So my change in resistance is 6%. Yeah, we need to apply this formula only, no? This formula. But if the change is less than 5%, so I can use direct formula, this one. If let us suppose in second numerical, we will do a numerical in which more than 5% is there. More than 5%. The last numerical, okay? Last numerical. One second. This is long row. The error is different. It is change. It is change. Error is different, no? In your 11th standard, change is different. Error is different. Error is always positive. Change is negative also. Look now. In second numerical, you will get this thing clear, no? Last numerical after this, last numerical. Last numerical. Look now. Last numerical. My wire is having resistance R. My wire is having resistance R. Okay, now we increase my wire's length by 30%. 30%. Find new resistance. One thing, I need to find new resistance. Second part, percentage change in resistance. Percentage change in resistance. These two things I need to find out. Look how we can do it. Look better. Simple, simple. If you are having 30%, if you are having more than 5%, okay, if your change is more than 5%, then always suppose initial at 100. Initial. So what is initial length? Sir, 100. What is final length? Sir, it is increased by 30%. Can I write it is 130 then? Easy. Initially it is, you need to suppose, now initially the length of my conductor is 100. Now I increase it with 30%, so my final will be 130. Always and always do like this. Always. Done. Look now, what is percentage change now? Percentage change. Sir, percentage change means final minus initial divided by initial into 100. Final we don't know. It is let us suppose R2. Initially we have R divided by R into 100. How to get R2? I know it is the length change, so I will write L2 only. What is R1 by R2? It is L1 by L2 square. L1 is 100. L2 is 130 square. 0, 0 cancel out. R1 is R. R2 is R2. 10 10 is 100. 13 13 169. 169. So I can write here R2 is equals to 1.69 into R. So therefore R2 is 1.69 times R minus R divided by R into 100. I will take R common, so cut out, it is 1.69 minus 1 into 100. I guess my answer is how much? 69%. Yes, so we change it, no? Look, length changes. That means we had stretched it. R square. Then percentage is, we need to just follow like this, no beta? Done? Clear? Any issue now? I guess we had discussed it more than enough in today's class. So rest thing we will discuss in tomorrow's class. Done, beta? Sundaram Srivastav, direct formula. Okay. Okay. So thank you, beta. Good night. Bye, everyone. Bye.